Okay, so let's get started. Hello, everybody, and welcome to today's webinar. This is the second in our Europe, Middle East, and Africa series. So we're very happy to have you with us today. Today's subject, we're going to be talking about Geosteering 101, and we're really getting back to basics here. So anyone who's new to geosteering, this is a really good session for you, and I hope you enjoy it. So during the session, we're going to be taking a deep dive into the fundamental principles of basic geosteering methods. And we're going to be covering model-based, stratigraphy-based geosteering and image log interpretation. So for those of you who don't know me, my name is Joanna, and I'm the Regional Manager for Europe for Rogi. I'm joined here today by my colleague, Romulo Huerves, and he is our Senior Technical Analyst. And also on the call, we have Alexandra, who's also my colleague, and who handles the business in Norway and the UK. So let's get started. Okay, so to start with, I thought we could just do a little overview and an introduction to Rogi, talk a little bit about who we are for people who have never heard of us. So Rogi is an IT company, and so we provide customized software solutions for the upstream oil and gas industry. So can everybody see the slides, or is it just Nicholas? Yeah, everybody can. So maybe Nicholas, if you want to join, try to rejoin the call, perhaps it might appear for you. Thanks for letting us know. Okay, so that just reminds me as well, just to mention, if you have questions, please use the chat box, and Alexandra is going to monitor the chat during the session. But really do ask us questions because we really like them. Okay, so getting back to Rogi and who we are. So we provide customized software solutions for upstream oil and gas. And to be more specific, we really work with real-time operations, and that's our focus area. We have a team of around 250 people around the world, and these are mainly software engineers, geoscientists, and mathematicians. And you can see from the map in the slide. So do we have another person who's not able to see slides? Perhaps Alexandra, you can have a chat to them. Okay. So as you can see from the map, our head office is in Houston, but we have offices throughout the Americas, also through Europe, Middle East, and into Asia. So today we have over 400. We have over 400 clients around the world, and these are mainly oil and gas companies, but also we do work with service companies too. And we have around 3,500 people using our software and our technology. And these users are mainly in the geoscience discipline, but also working in drilling, completions, and data analytics. And just one more thing I want to mention here is that our technology is also used for conventional and unconventional projects around the world. So if we move to the next slide, this is a little slide describing the outline of today's webinar. So we're going to start with a brief definition of geosteering and what that is, but also why geosteering is important. And then we're going to run through some of the techniques and methods that we apply as geosteering professionals during the drilling of the well. And then we're going to have a live demo in our StarSteer software, and we're going to run through a real-time project. Okay, so first, the definition of geosteering. So here I've put together two definitions, and the top definition is from the Rogi knowledge base. So for our customers, this is a platform where you can find out all kinds of useful information about geosteering and Rogi's internal projects, products. So from our knowledge base, the definition of geosteering is techniques and methods applied during the drilling of a well to know, firstly, the stratigraphic position of the trajectory, and secondly, the structural trend of the geological objective. And this is in order to guide or navigate the trajectory within the best properties of the reservoir in real time. I've also added a second definition. So this one comes from the SLB Oilfield Glossary, which is a public resource and available online. And they describe geosteering as the control of the direction of a well based on the results of measurements derived from downhole geological logs, and generally in order to maintain a directional well within a pay zone. So there you go, two different definitions, but essentially meaning the same thing. So moving on to why geosteering is important. So we've narrowed these down to three main points. I think you can quite easily categorize everything into these 3 points. So the first one, of course, is, I suppose, the most obvious, which is for optimizing well placement. So what we can do while we're geosteering is to optimize the well path, but also to place the well bore in the most productive zone. And this is to help us to improve or reduce drilling times and costs, and also to help extract hydrocarbons more efficiently. The second point is about reducing drilling risks. So as we're geosteering, we can actually use our technology to avoid hazards in the subsurface. And these can be things like unstable formations, faults, or geologically complex zones. And added to this, if we're working in real time, drilling engineers and geologists can be making informed decisions on the fly. And this is really important because it allows us to adapt to any unexpected changes in the subsurface and optimize our strategies as required. Now, the third reason why geosteering is important is for understanding the subsurface. So through the use of LWD data that's streamed in real time, geosteering professionals are able to create quite advanced and robust models of the subsurface. And these are really important because they help us to understand what's going on in the subsurface. And it's quite valuable for the development and production of a reservoir. So let's go to the next slide. Romulo, perhaps you can explain to us the role of geosteering.
Yes, thank you, Joanna. So to understand the role of the geosteering, we need to start from where the uncertainty come from. So we start with the geoscience team that build a model looking the data in different perspectives, like analyzing the core, study the sediments to understand the formations, analyzing the petrophysics to understand what is the best properties of the reservoir, and to understand or analyzing the seismic to understand the general trend of the structure, the main faults in the reservoir. So based on that, they build this model. Once they know where is the area, they determine the area to be drilled. So the drilling engineers start to build a plan. Okay. But what happens? So we know there are a lot of uncertainties when you make correlation from one well to another well. We can find lateral changes in between. We can find local faults. We can find pinch outs in between wells. And also we have a limitation in the resolution of the seismic. So that led to uncertainty in the TVD. So during the landing, the direction of drilling follow the geometrical plan, and there is uncertainty where to land. So in this point, the geosteering team enter, okay, and he will use the LWD logs, the logging while drilling logs, to build a model in real time and to adjust the trajectory inside of the reservoir, inside of the best properties. So I have some example here. So in here we have an unconventional reservoir. This dashed line is geometrical drilling, the geometrical plan, sorry. And so we land the well using the geometrical plan This is a case of in Argentina, Vaca Muerta is an example. So once we are there, we can visualize the geosteering team can visualize where is the best properties, where's the desired properties to be in the reservoir. So like high gamma, high Young model, high DOC, low water saturation, high porosity. So we can follow that particular properties and navigate inside of this area along the path. Okay. Another model we have is another example of conventional reservoir. So we have a sill rock, we have reservoir rock, and in this case there is like a high water saturation. Okay, in the geometrical plan, this is the geometrical plan that proposed to drill near to this high water saturation, and then there is a reactive trajectory that they start drilling, they enter to the reservoir, but they start building inclination faster to avoid a high water saturation, and they exit to the top, as you can see there. But the aim of the geosteering is like based on the LW data we have, we can map this contrast. We can map the contrast from the sill rock from the top and actually navigate the well, place the well along the top area of the reservoir in order to get more production. Okay. So let's talk about the techniques we use in real time to build the model. So I'm going to talk about 4 levels of techniques we can apply. So level 1 is model compare update. Level 2 is stratigraphic correlation to vertical thickness. Level 3 real-time deep determination from azimuthal measurements. Level 4 remote detection of boundary resistivity. All these techniques combined give you a solid model in real time. So I encourage the people to actually mix these techniques because one technique sometimes is not enough to solve the structure of the reservoir in real time. So let's start with first level. This is a model-based technique, and so we take the type log and we project this type log along the lateral section and adjust the model. So in this example, I have here my type log well. I propagate this type log along my lateral section, and while I'm moving the deep inside of my curtain section, you can see I have a synthetic gamma there. That synthetic gamma represent what the trajectory is crossing in my model. So the aim here is to find the apparent dip that match with my actual gamma in real time.
So Romulo, just to ask you a question, if you're working in a conventional reservoir, could you apply the model-based technique? Is that suitable?
Well, actually, this technique has a lot of limitations, and for conventional reservoir, we need to use another technique to support that. So I'm going to show you some limitations of the model base. For instance, if you encounter lateral changes between your type log you are propagating along your cross section, you won't be able to model that. So my dynamic log, my synthetic log, my black log here won't be able to react and match this scenario because I am finding lateral changes in between. Also, the ambiguous log response means like these logs are not azimuthal logs, so you cannot tell from where if I'm crossing up or down the layers because you don't have control of the stratigraphic position in that point. So you can end it with different interpretations and the same log response there. Okay. Now let's talk about the level 2 is the strat-based geosteering technique. In this one, we use the actual log, the real-time log, and we project that log into vertical thickness. Then we are able to squeeze or stretch this log to find the apparent dips. As you can see, I can divide the actual log, which is this one, the red with colors and colorful logs, and the background log is my type well log. So I can follow the stratigraphic correlation. I can take a piece of segment of the log and I can look up and down these fixtures to correlate the type log with my real-time log. And as you can see, I'm able to create some faults by looking up and down the stratigraphic correlation there.
Okay, so just another question, Romulo. So earlier you were looking at gamma ray.
Yeah.
It looks like you have several different logs here. So what kind of logs can we use for this technique?
And now in this example, I'm using gamma, but you can add several logs. You can add density, porosity, so the logs that give you information about the stratigraphic position. In this case, in this example, I have two techniques combined. As you can see, the model base here is also reacting, and my dynamic log and my strat-based correlation. Okay, let me explain you why we use true vertical thickness to project the real-time log. For instance, this is an example here. I have a vertical weld across this layer once, and this is the response of my vertical weld while crossing this layer. But the horizontal weld has a different response. So I can see the same fixture, but a little wider because I remain more inside of this layer. But what happens when I'm drilling upwards in the layer and I remain too much in the same TBD position? So I will get this overlapping log that is going to be impossible to correlate with my vertical log, as you can see there. So well, you project this real-time log in TBT, you are able to take this log like this and squeeze or stretch this log, as you can see here, to find the apparent dip you are obtaining, and also to follow the proper stratigraphic correlation. Okay. So another thing, another important advantage of this technique is like you can catch lateral changes. For instance, if you have information around your reservoir with different wells, you can add these tie wells in the strat base in my vertical track here. I'm projecting into vertical thickness, and can catch lateral changes. In this case, I drill. This is an example. So we enter here inside of the reservoir and we saw a massive sand body. So it's a clean gamma. And suddenly when we keep drilling the horizontal part, we find out a high gamma peak. So by knowing exactly where you are in the stratigraphic position, you can look around between your different type wells you have around your different neighbor wells, and you can catch this response and keep correlating with that type well. So this is the advantage of these strat-based methods that allow you to understand the stratigraphic position and also to follow lateral changes if you have the information in your field around in other type wells.
So just to ask about type wells, how do you choose the most appropriate type well or selection of type wells? What's your recommendation for that?
Well, basically, we use the tie well near to the landing area and tie wells near to the lateral, close to the lateral section. And yeah, you can see in the correlation panel, like in which tie wells you can find lateral changes or no, if all of them look similar. So you can use the most representative ones and close to your lateral well. Another technique we use also is based on cuttings. It's called Geosteering and Biosteering. So sometimes you are in a massive limestone and the gamma is really flat. So you need to follow particular elements or minerals inside of the reservoir. Like in this case, I don't know, like you need to be more in area with more magnesium than calcium, or if you are doing a radioactive sand, you need to the gamma is also radioactive inside of the sand. So you need to follow a particular mineral. So in this case, you can bring this data and use the strat base and the model base method to understand where you are and to follow that particular mineral or element. Now let's talk about the level number 3. In this one, we are using azimuthal measurements. In this case, image logs. So the image logs are useful because they give you the depth of the structure. We can calculate the depth of the structure. So they scan the borehole around the borehole 360 degrees, and you can see some sinusoids or fixtures inside of the image. So when the well crosses down the layers, you can see the fixture starting appearing in the middle of the image, and that ended in the borders of the image. When you drill up, when you cross up layers, the fixture is starting to appear on the borders of the image and ended in the middle. So we call that fixtures subphase when you are drilling down, and small phase when you are drilling up. And then also you can recognize another fixtures when you are parallel to the inside of the layer. Okay, here there's some examples where you can see in the real-time image. So we can make some like a pick some the dips inside and visualize the apparent dips on my cross section. Okay, and that allow me to be more confident in my model. So in this case, I have three techniques simultaneously. I have model-based technique. My dynamic log is matching my real-time log. My dynamic image log is also matching my real-time image log, and my stratigraphic position is tied to. So this is the three methods we are gonna visualize in the demo in Stratigraphy. And
just so,
another, yes,
just sorry to interrupt you.
that is okay.
I was wondering, so it's when you're actually running a real-time operation and you've got all these different techniques that you'd like to sort of use simultaneously, does it not get a little bit overwhelming with a lot to actually do
Well,
at the same time?
actually, in this software, StarCU is actually quite user-friendly. So you can jump from one technique to another technique easily, and all of them are simultaneously integrated there. So it's not like a big effort to jump to another software or to, I don't know, to do like too much clicking to pick another technique. So they are actually integrated.
Okay.
Okay. Another technique is level 4. In this one, this is the remote detection of boundaries resistivity inversion. So this technique we call proactive geosteering. Why? Because in the previous technique we saw before, so we are relying on logs that they doesn't have too much depth of investigation. So for instance, this is my gamma, and it's actually placed quite far from the beat. So by the time I'm seeing the response, I actually inside of that like a control. So I'm really in there to visualize what response I have. But the resistivities propagation tools allow us to see the contrast or the resistivity contrast from the distance. And depends on the tool, I can have deep azimuthal resistivity or ultra deep azimuthal resistivity. For instance, the bulk resistivity can give you between till around 5 feet of investigation, deep azimuthal resistivity around 15 feet of investigation, and ultra deep, which is not here, but the ultra deep is actually the double of the deep azimuthal resistivity tool. So it's like a 30 feet from the borehole. So you can actually geosteer or change the inclination in real time before reaching that contrast, the resistivity contrast in the top and in the bottom of your reservoir. So here,
actually,
yes.
So Romulo, so it sounds like you can actually achieve a lot with the resistivity tools, the deep and ultra deep. Are there situations where it's advised to use them, and other situations where they're not, or would you recommend them for most situations?
Well, so depends. So I will use resistivity tools if I have a good contrast in my reservoirs. Means like if I have the resistivity contrast from my top or from my bottom in my reservoir is sharp. If I have a good contrast, I will use the resistivity tools because I will able to map this contrast from the distance. But if the contrast is soft, the resistivity diversion won't work there, and you will end it like crossing another reservoir, and you won't be able to understand the stratigraphic position. So I always encourage you first to evaluate the resistivity contrast in your reservoir or also use another technique to support the resistivity inversion. In here we have some examples of resistivity inversions. So the resistivity inversions brings, so is a azimuthal resistivity logs that scan the rocks around. So these azimuthal resistivity logs let me know from where the contrast is coming. So in this case, when the resistivity drops, means like the contrast is coming from the bottom, and when the resistivity rises, because the contrast is coming from the top, and so on. So that allowed the software to create inversion, and for me to visualize it easily, that contrast, and to guide the reservoir inside of the to guide the trajectory inside of the reservoir. So this is also another example how the resistive inversion looks like, and how people can change the inclination there. In this case, we have an integration of 4 techniques. As you can see, a strat-based, model-based, over here, image log deep peaking, and resistivity inversion to create a solid model in real time. Okay, now let's go and have a look at the Stratigraphy. I will show you a project I have here using 2 techniques. So in this project, I have the well is already land inside of the reservoir. I have dynamic logs, a dynamic image log. I have a real-time image log, a density 16 channels image log, and I have density and porosity logs. So this is the interface of the Stratigraphy. If you go to mode, you can apply different techniques. So you can do geosteering using model-based and strat-based. You can do resistivity inversions. You can do image log interpretations. So I go for geosteering interpretation, and then I can, as I explained before, I am projecting this red log here is my real-time log, and the black log behind is the log from my tight well. Okay, so when I stretch this log down, as you can see here, to find correlation, I am obtaining an apparent dip here in my cartoon section. And also, if you can see it again, when I stretch it down like this, my dynamic logs and my dynamic image log also change, and they should match with the real time. So I'm applying here 2 techniques simultaneously. Then I can go to mode and go to image log interpretation. I can adjust here the investigation depth. 4 I would put, and the diameter, the hole diameter of 6.5. And then now automatically when I go to this technique, I have active a top set to put my dip peak in there. So I can rename it. Let me put dips here to know those are my dips. And then I can start doing the dip picking. I can increase here the scale a little bit. I can zoom in, and I can start doing my dip picking like this. I can also scale the palette here to highlight the fixtures inside. So as you can see, I am obtaining here. Let me make it red, so it's quite handy to customize. You select the object, go to the format of that object, and you can change the color. So now, as you can see, I can visualize it better. So I am getting these apparent dips here, as you can see on my trajectory, that actually match with the apparent dip I did with the strat base. And you can also check the split sheet and see the geosteering dip I'm getting. Okay. So let me load more data here. So actually, let me show you something. So if, for instance, if I know now that I'm in the lower area of my reservoir, so I'm actually, let me go to mode geosteering. I'm in the lower part of the reservoir here, so I can create a target line to project ahead. Target line, and this target line allow me to project with a constrained dogleg. So I can put dogleg of 2, for instance. Can extend this target line So that allowed me to place or to project, to deviate the well and place it in another area. I know, like, okay, I am inside of this lower area. Maybe I want to go higher. So I can also extend this interpretation. So if I click in the interpretation, I can extend the interpretation like this, and I can actually add my grids tendencies inside of this extension. So I know, okay, now I am getting a high apparent dip, but based on my grids, it's going to be more soft, the apparent dip. So actually I can project this target line to be, if I want to cross again to the upper part, I can go here, I can put it there. Okay, and if I am okay with that projection, for instance, I can create a plan to reach that point here with the dogleg of 2. So I can click here, create. I actually can add here how many, the density of the surveys I will include into my new plan. So once I'm okay with 30 meters per survey, I click here, create, and a new plan appear. Okay, so this is going to be my new plan to build again and reach this area of the reservoir. And then I can send this to the directional drillers. So this is my projection, or to reach this certain TVD with the maximum of dogleg of 2. Okay. Okay. Then I'm going to add more data here. Yes.
Romulo, can I just ask? So if you're
Sure.
drilling, like you're geosteering in real time, and there is you've come across something that you want to recommend a change in the trajectory, how do you communicate that to the operations team, to the directional drillers? What's the best way to do that?
Well, we have a solution we have a solution in the Solo Cloud called Starlight. So this application allows you to visualize what the geosteering engineer is doing in Stratigraphy. You can visualize in your phone, in your tablet, so they can see any changes I am doing there, and we can talk through this app. And there are another channel, so it depends on the client from where they want to communicate. Like, we can go for Microsoft Teams meetings, but so we have this app to visualize what I'm doing in real time, and we can set some alerts, so the manager can set alerts based on ROP, based on how far the trajectory is from the top or from the bottom. So there are different choices to set alerts there. Okay.
Okay. Okay. So maybe we'll talk about that in a future webinar then.
Yeah, will be great for sure. So I'm going to load. So in Stratigraphy, you can drag and drop data to load. So I'm going to load the second survey here. So I choose MD, inclination, and azimuth there. And the action is merge. So I'm merging. So I got more trajectory. And then I will also drag and drop more last file. So I'm going to merge gammas, density, and porosity. Okay. And I will add another piece of my image log. So in the image log, we need to select the channels. As you can see, we have 16 channels here, the first and the last one, and the action is going to be merged with the previous one. Okay, so I got a new data. Okay, this data can be loaded manually, as you can see, drag and drop it, or if we are working in real time, you can connect here in data, and you can go to the service and data, and you can connect your project through WITSML to load data in real time to the WITSML folder. Okay, so now I'm gonna keep picking more features in my image log. So I go to mode, I go to image log, and then I will pick a few of them more, for instance, like this. Okay, this is like dipping down here. So you see how easy it is to pick the dips, but they are really sensitive. So it's good to support them with the with your strat-based method or another technique. Is important.
Okay.
I'm picking more dips there. This. And yeah, once I'm agree with that, I can come back here to Geosteering and keep doing the interpretation here. So first I will create a segment to fix my previous correlation, which is this one here. It's all set there, all good correlated there. So now I have this piece of segment. I can stretch or squeeze it where to put it. So now I can, for instance, I can add a segment in this area because I know I am quite parallel now to the layer, as you can see the image here. So I will add a segment here. So I can make it this segment a little bit parallel to my trajectory. And now you can see how my dynamic mesh log match a little bit with my real-time log there. Then I can add another segment in this area that suggests it's like a dipping down. So I can actually take this segment and stretch this log up to find correlation. As you can see, I have a good correlation with my density and dynamic and porosity log, but with the gamma, it's not too much. There is like a lateral changes, as you can see there. So there's like a lateral changes there. So let me just fine tune this here to correlate it properly with the density. And as I'm doing this correlation here, you can see how my apparent dip match with my dip peaking I did before. So it's dipping down in this area. And if I follow just the gamma, I will miss this interpretation, because if I just using one log and one technique, I will end it with another interpretation, like going down instead, like a follow, trying to catch another fixture, another correlation there. That's why it's important to use more than one technique because this technique allow me, okay, this log tell me, okay, the correlation is above, not below, and the apparent dip is not dipping up like this, it's dipping down like this. Okay, so that's why it's important to use different techniques to build a solid model. Yep.
I've seen that we've had quite a few questions, right, Alexandra? I've seen you've answered them.
Yes, we did, and actually, me and some other representatives from Roger have answered most of them. I was just wondering to ask you, Romola, could you please show how to create a fault? Because we have a couple of questions about faults. If we could add faults to our cross section.
Yeah, sure. So it's quite easy. So for instance, if I grab this segment from my strat base up and down, instead of stretching or squeezing from the borders, I can take it completely up and down and look correlation above or below. So you can actually end it with interpretation like this, but actually this is the opposite cross between my density and my neutron. So it's not the same. And so you can find like another correlation up and down, depends on what you expect in your model. So it's also important to integrate here seismic. We can visualize seismic image or a seismic cube. We can load the seismic cube into the cloud and visualize the slides parallel to the azimuth of my trajectory in the background, or we can add 3D models and also visualize what the geology, the paleo environment is expected there, like I don't know, lateral changes during my lateral section.
It's also possible to add seismic data, is that right, Romulo?
Yes, exactly. Yeah, it's possible to add seismic data there here. So we can load this seismic data into the cloud, and then we will visualize it in the cross section.
Okay.
I'm just gonna finish this correlation here. I'm just correlating this log that is overlapping in this area here.
Well, you make it look very easy, Romulo.
Well, that takes practice, I think, where practice makes perfect. Actually, it's easier to once you practice with the strat base, you can quickly find out the how can be the answer in the strat base. Okay, now I can add the last piece of data, or I can show you, for instance, how to project again. So now we know, like, we are near to the base, so I can come back here to my target line. Okay, I can edit the target line. Let me edit the target line. I can take this target line and move it upwards here. Now I know I'm really like close to the base, so I need to actually build inclination to place my well inside of the upper part of the reservoir, like this. Okay, and then again I can create a plan. So I constrain this trajectory. For instance, if I want to do something more aggressive, the projection won't come, because I'm constrained this projection with 2 of dock like now. And then I can create like another plan here. So I can send this plan to my directional driller. So this is my plan to build inclination. I was in 89.6. I will recommend to build. So using 2 of Dockleg to reach this TVD, or TVD sub C. Okay. So this is how we can project ahead. Another important feature we have here is the statistics. So the statistics allow me to know how far I am from the top. So based on my last survey, I know like I am from the top of the reservoir 2.48 below, and actually just 0.18 above the base of my reservoir, based on my last survey. So this information can go through the report, and yeah, it's quite handy to visualize it there for the report.
Sure. I guess it's just the statistics to help you understand how efficient your well path was.
Exactly.
So, yeah.
Yes. Okay, I'm going to show you quickly another feature here. Important is like when I'm working with the target line and I'm projecting the target line here with a different azimuth, I can visualize that in my cross section. Target line. Edit target line. Okay. This is my target line. Let me remove this section. So for instance, this is my target line. Okay. So I'm taking the target line to another area. I'm projecting this target line here. Okay, so you can see the extension of my interpretation, how they looks like. So the grid shapes the apparent dip or the structural tendency in that particular area where I'm placing. So it's good also for planning. So you know what you can expect if you change slightly the azimuth. The apparent dip is gonna be it's gonna dip down harder. So you need to actually instead of building inclination, or instead of keep building inclination, into drop inclination if you are choosing another azimuth. So it is quite practical to visualize the tendency on your moving the target line around your map and visualizing the cross-section response projection there. Okay. So I think we are already, we have 1 hour already. So let's talk about last webinar.
Yes. Okay. Well, thanks for that demo, Romulo. That was really interesting and very
Pleasure.
insightful. So as we're wrapping up today's webinar, I hope it's given you kind of a nice taster and perhaps encourage you to get a little bit more into geosteering. If you want to learn more, we're actually, we have an online course, Introduction to Geosteering, and that is, I think it's on the 12th of December. So get in touch if you're interested in that, and I will send you the link and the details. We also provide in-house training. So if anyone's interested in organizing training for their team, just let us know. So we're going to take a break over Christmas. Hope you guys do too. And we'll be back in January. So at the end of January, our next webinar will be on resistivity inversion for enhanced well placement, and we'll get into the theory there. And we'll talk about the tools and techniques in Starsteer. So I really hope you enjoyed today's session. Thanks once again to Alexandra and Romulo, and hope to see you guys soon. Thank you.
Yeah, thank you everybody to join the meeting.